any questions over any of the assignments thus far? Any questions over 10.1 through 10.5?
Is that what we talked about today?
No, that is Algebra 2.
Alex?
Not too bad.
What if we just all walked out to skip this class?
You would all be more truant, and they would come after y'all.
Hey, not if you're 18.
That's. You still are required to be here. Guys. So, what we're looking at today is, to start off with, is the segment of chords theorem. If two chords intersect in the interior of a circle, then the products of their segment lengths are going to be equal. So, we're going to go to this one first. I want to skip those first two and come back to them. Guys? Guys. So, we found this problem here, yes? We're on this one here. So, according to this theorem, if two chords intersect inside a circle, then the products of their lengths are going to be the same. So here we're saying that this segment times this one is going to be the same as this segment times this one here. They're going to be equal. So if we want to find the value of x,
So it'd be x times 3 and 4 times 6.
x times 3 is going to equal 4 times 6. So x times 3 is 3x. 4 times 6 is. So what do we need to do next to solve for the value of x? 24 divided by 3 is? Hey. Questions on this here? Okay. Are you ready for the next one? So if we look at this one here, so we're saying that this segment's length times this one is going to be the same as this one times this one here. So we have what? 2 times x plus 1 is going to equal 4 times 3. Now 4 times 3 is what? On the other side, we can distribute the 2. 2 times x is plus 2. The next thing we'll need to do to solve for the value of x is subtract 2 from both sides. And if we subtract 2 from both sides, we simplify. 2x is equal to? And that's all we need to do for this one here to solve for the value of x. Yes. Huh? Different reasons. Yes. So any questions on these last two here? So we see how this property works, yes? Okay, I want to go back to the first two. And the reason I skipped this is not because they're any harder than what these that we just did. I want us to see the property first. So if we're looking at this here, this length times this one here, so x plus 2 times 1 is going to be the same as our x times x plus 4. So the property still holds true. It's still the same, but the numbers that we have this time have all variables in each spot. Now the first set, we're going to use the distributive property. So x times x is x squared, because anytime we multiply something by itself, it's being squared. X squared. Now x times 1 is plus 1x, or x. Then we do the same thing with 2. 2 times x is going to be plus x. And lastly, 2 times 1 is almost 2. So that's using the distributive property for the first part. Now the other one, we're just going to multiply everything by x. So x times x is plus x times 4 is. Any questions on this so far? Because each of the 4 spots has a variable contained in it. Now, the next part will be combining like terms. X plus 2x is. Now, whenever we have a variable to a power greater than 1, so x squared, we try to get everything on the same side. So the first thing we can do here is to subtract x squared from both sides. Well, on the left-hand side, x squared minus x squared is 0. On the other side, guys, x squared minus x squared is, again, 0. So when we subtract x squared from both sides, we get that 3x plus 2 is equal to 4x. So subtracting x squared from both sides worked out that they all eliminated out. Now we just need to solve for the value of x. So what would we do next? What steps?
Plus 2, minus 2x.
Since we have 3x and 2 on one side and just x, we can get them on the same side by subtracting 3x. Because 3x minus 3x is, so we're left with 2. 4x minus 3x is, x is 2.
I would have been the dumb one to put 1 divided by 2.
Now what did it ask for? So it wanted the length of ML and JK. So for this here, ML is this entire length. JK is this entire length. Now, if we plug x back in, this one here would be 2. Up here, we have 2 plus 2, which is 4. Here, x plus 1 or 2 plus 1 is 3. And lastly, 2 plus 4 is 6. So ML would be 4 plus 3, which is 7. JK or KJ would be 2 plus 6, which is 8. So our two lengths are 8 and 7. If it was to scale and the same scale as the tape measure, then it would work. Questions on any of this here? All right. Let's look at the next core concept, tangents, segments, and secants. Now, these are going to work together. Now, a tangent segment is any line segment that intersects the circle at exactly one point and goes off in a single direction. A secant segment is broken up into two parts. We have the part that's outside the circle and the part that's inside the circle.
Inside and outside the circle?
Mm-hmm. Because the whole thing makes up the secant line. Part of it is outside of the circle and part is going to be inside. Now our first theorem out of the two here is going to be dealing with two secant segments. And if we take the part that's outside the circle and multiply it by the whole length, it's going to be equal to the other secant segment's part that's outside of the circle times the entire length. So if we're looking at this problem here, guys, here the outside part would be 9 times the whole line, which would be 9 plus 11, is equal to the other line's exterior part, which is 10 times the whole line, which would be x plus 10. So when we have two secant lines, it's the exterior times the whole is equal to the exterior times the whole line. Now we just need to solve. Well, we can do 9 plus 11. 9 plus 11 is 20. Can we add x and 10 together?
Yes, we can.
Because are x and 10 like terms? No. So it's going to stay x plus 10. Gosh. Now we can multiply. So 9 times 20 is? 9 times 2 is? 18. So we can put the 0 back and get 180. Now on the other side, we can distribute the 10. 10 times x is? Plus 10 times 10 is? Now what do we need to do next to solve for x? We need to subtract 100 from both sides. Now 180 minus 100.
Have a good day.
So 180 minus 100 is? 80. Equals 10x, and our 100 minus 100 simplifies to 0. Now what do we need to do next? And that's all we need to do for this here. Any questions on this here? Let's look at the next one. So this here is working with the same thing. We have two secant lines. And the way that we can solve for x is using our formula that the exterior of one of the line times the whole. So 3 times 3 plus 9 is equal to the exterior, 4 times the whole, now we look at this here, we can do 3 plus 9. 3 plus 9 is? Almost.
I am so down.
12. Now we can't add x plus 4 because they're not like terms, so we can leave that there. Now we can multiply. 3 times 12 is? On the other side, we can distribute the 4. 4 times x is going to be? 4 times 4 is going to give us? Now what do we need to do next? Subtract 16 from both sides.
Hey, it's still about 28 minutes.
Logan? Then,
Divide by 4, which is 5.
and that's all we need to do for this here. Do you feel comfortable with this? Okay. Now the other type that we have is if we have a secant line and a tangent. Now for these here, we're going to square the tangent line's length and it's going to be set equal to the exterior times the whole. So the only difference between this one and the one before is that we have a tangent segment that will be squared. So we're not going to worry about that next one. And we're going to look at this one here. So we're going to skip the one that's finding RS, and we want to find WX. So this line segment here, W to X, is going to be the tangent because line segment does not intersect inside the circle. And according to the theorem, this line segment's length is going to be squared. And it's equal to, so the exterior of the secant line times the whole. So x squared is just going to be x squared, because x times x is going to be x squared. Now, the other side is going to be 12 times 12 plus 15. And 12 plus 15 is 27. Now, our next thing that we're going to do is multiply 12 and 27. And if we multiply these two together, we get 324. Now, what would we do next? We're going to square root both sides. And again, at this point here, we can plug that into the calculator. We can plug the square root of 324 in, and we get 18. Because the square root of 324 is 18. That's it. Yes. No, because the square root of x squared, these will cancel each other out. Because when we take the square root, we're looking for what times itself is going to be that. Because x squared is x times x, so we get x. And 18 times 18 is 324. Any other questions on this here? So here we're going to take the exterior, the tangent, and it's going to be squared is equal to the exterior length times the whole length. So we're going to have x squared is equal to 1 times Guys, I am done with the extra noises. So, if we're to finish this here, what do we need to do? We need to square root both sides. And the square root of 4 is 2. Any questions on this here? This here, I believe, because we do have 2 left, this one here and one other, and then we are actually almost done. Because I think, yep. If we look at this one here is a little bit different because this time the tangent segment's actually given to us. It's our 7. So here we'll have 7 squared. is equal to the exterior length, which is times the whole thing, which would be 5 plus. Now we can simplify some of this here, because we can simplify the 7 squared. 7 squared would be 9. Here we're going to distribute the 5. 5 times 5 is 5 times x is. Now at this point here, we just need to solve for the value of x. We need to get x by itself. We can do that by subtracting 25 from both sides. Now our 49 minus 25 would be 24. These here become 0, giving us 5x. Lastly, we divide both sides by 5. So we can leave it as 24 over 5, or, yes, 4.8. And that's it. Any other questions on any of this here? And that's it. So your homework is on page 517.